Hello from Amsterdam. I'm tuning in the evening here. My name is James. I'm a sustainability consultant at Metabolic, and a lot of the work that I do is around circular manufacturing and circular supply chains. I've also written a report on the circular potential for beverage containers in the US, which is relevant to our last session, and I put that in the chat as well. But I'll be talking mostly around our work on electronics and some of the research we've done on critical metals and what companies can do to assess risk through a metal criticality framework. I guess I'm not joined by Sebastian right now. But
okay, you can join. Why don't you just do a quick presentation and overview on Metabolic? I'm really excited to work with Metabolic. I've been reaching out to organizations over the last 2 years and just really aligned with what Companies for Zero Waste does. So thank you, James.
Yeah. Of course, yeah, happy to join in. Yeah. I'll give a brief introduction on Metabolic and the work that we do. So we are a sort of network ecosystem of arms, and our overall goal is to transition the global economy to a sustainable and circular state. And we do this through a variety of mechanisms. I'm working at the consultancy arm, so I work mostly with industries, but we also have a cities arm that is focused on helping companies and cities with their sustainability and circularity issues. And a lot of our work is around impact assessment and around really strategic systems thinking around how to manage materials and trade-offs between the different options that we have for moving towards a circular system. We also have an institute that does a bit more public funded research and long-term projects and partnerships with institutes, other research institutes, but also government grants and academic partners. And where we find gaps in the system, we have a ventures arm that fills in systems. We have a renewable energy and off-grid energy startup called Systemic. And that's a place for us to get our hands dirty and create new things from the systems that we've been assessing from our consultancy and institute space. We also have a foundation that does a variety of work around materials recovery. And we also have the software arm that creates tools for transitioning this really important circularity goals on a larger scale. But the topics that I want to talk about today are really focused on the materials in electronics and around circularity. This is an emerging field that's super important for companies to be considering for risk reduction. All the materials that are in electronics, they're becoming much more complex and difficult to recover, but also are associated with a variety of economic, social, environmental supply risks that have direct potential to impact businesses. And it's really important for companies to have a grasp of where these risks are and what they can do to mitigate these risks moving forward. This is an analysis that we've done. We're really using critical raw materials at an exponential rate. And this is a forecasting of really important metal demand for wind and solar energy between 2020 and 2050. Really complex assessments, but the materials that we're using for these wind and energy technologies are also really important for the electronics that we're putting into our system as well. And at the same time, we recognize that the materials that are being put into these systems are also coming from a handful of highly concentrated countries, which adds risk to supply chains and difficulties around sourcing potentially, especially as we're accessing the difficulties that we've seen in COVID-19 this year, as was highlighted in the last presentation as well. At the same time, there's a really important gap in the recovery of these materials. And at the moment, production is on the rise, but producers and recyclers need to really align on incentives and design the system to recover these e-waste materials at their end of life. So what can be done? That's a really high-level topic around the issues that we're facing. But companies are really need to see themselves as part of a system where these materials are able to be circulated at high value, while recognizing the limitations of the current recycling and metallurgical processing around what can be recovered back into its raw material form and what is sort of lost in the system from a pyrometallurgical or high impact recovery space. But what's really important here is to think about how materials can be tracked through this system. So from our initial presentation with Everledger, for example, how to track the material from the raw mining and the mining industry through the commodity market, through the manufacturing phase, into the component piece, assessing how brands are then interacting with their consumers, and then how that material is then processed back into the recovery piece through the recycling process. What's really interesting here is, of course, in a circular system, that the tracking of materials is for metals at least, it's always going to be combined back in with the raw materials from the mining industry. And those risks that we see in the mining industry can be assessed through types of frameworks to assess the social, environmental, and economic risks around sourcing electronic materials, for example. I'm going to highlight, there's also plenty of discussion that we can talk about for how to recover materials through the formal collection system, around regulations around the formal system, but around 80% is still exiting this, being processed through more informal, undocumented e-waste systems. And that's a whole different conversation that we can dive into. But I really want to focus around assessing the risks with the raw materials and critical metals in our electronics products. So what we've done for some of our projects at Metabolic is building on some of these risk assessment frameworks to match some of these socioeconomic availability risks directly with the materials in electronic component products, so that companies can make more informed decisions on prioritizing materials for strategic interventions. So first I'll talk about the framework and then how it can be used within the electronic system. So if we look at, this is one example of a material criticality framework. And looking at a variety of indicators allows you to assess trade-offs between social compliance standards of mining and producing materials for electronics, the environmental impacts associated with producing those materials as well. But I think what a lot of people in this call are probably interested in is what are the different socioeconomic availability risks. So that's the political stability of the producing countries and that is mining that material, the trade barriers associated with actually getting that material to where it needs to be, the company concentration of mining certain products and certain materials, whether that metal is occurring as a co-product, so underneath a base metal that is then priority metal, but then is sort of an additional metal that is reliant on the mining of a core base metal in that system. So by sort of assessing all of these different risks together, you can identify materials that are really driving the risk associated with the production of your product. So what we've done, and this was mentioned as well in a previous step, is that you really need to look at the digital twin potential of assessing the materials in the components that are in electronic products. A lot of producers, and it's sort of hard to know exactly what materials are in the components that you're putting into your products, because you're relying on manufacturers that aren't directly under your own operational control. So what we do is we take the bill of materials of different component parts, link them with life cycle assessment, electronic databases focused on electronic materials, being able to then extract the raw material data associated with the production of those electronic parts, and then overlay these risk frameworks on top of that to identify which of the different materials have different risks and different trade-offs associated with that production. You can then take that type of framework and identify exactly which component parts are driving that risk score higher. So for example, tantalum and capacitors has a high risk score for some companies that are assessing their products through this framework. And then you can identify which materials and products are driving that consumption of those specific component parts. We see gold, silver, and tin, platinum group metals, copper as examples of types of materials that are especially important for driving these risks throughout the supply chain. It's then important to think about, okay, what are the risks, and then what are the strategies to go about reducing these risks? And one of the pieces that it's important to consider is how the recovery of these metals currently fit within the metallurgical and the end processor. So once it's being disassembled and put back through the system, the PCBs are then going back to the smelter and then recovered through these different processes. And some metals are just going to be lost in the process. If you prioritize the recovery of nickel and copper, for example, that's a pathway that you're able to recover certain metals from, but then you're going to potentially lose other important metals from the system. And that's with the existing infrastructure that we have in place, of course. So if you're going to lose some and aren't able to recover in especially complex and increasingly complicated electronic products, the recovery of those isn't going to be possible. So it's important to think about potential redesign of your product to either fit into existing recovery processes or be able to reuse that component at a higher reuse level rather than putting it back into the system at a elemental level. So that's a way to sort of consider the techno-economic limits of your recovery system under the lens of prioritizing metals for risk reduction. I realize it's a complex slide, and we can dive into that in a bit more detail after I hand off to Sebastian to discuss other emerging technologies that have also less impact potentially for the recovery of critical raw materials within the system. So I realize I've gone through these in quite a bit of quick high-level detail, but I want to give time to Sebastian as well to discuss this, and then we can have a bit of a discussion at the end, discussing, yeah, exactly the recovery processes and the importance of collaborating across the industry and getting out of our silos to drive this change forward.
Outstanding. Yeah, thank you. Does anyone have any questions right now? It's quite a bit of information here. Is the United States ready for this? I mean, right now, where are we in this stage and the learning process from your lens, you know? Like,
yeah,
there are raw materials. When you talk to big corporations, or you're talking to government, do they recognize this technology? Is it complicated to them, or, you know?
It's a complex system that is definitely viewed from a regulatory lens, and I think companies are taking note of that you know, you need to take additional responsibility for these. I would say there's leading companies that are definitely aware of this as a concept, and I think sort of the networks of companies that are definitely thinking about this. But I would say that the infrastructure to recover, and I think our electronics recyclers in the room might be able to speak to that a bit more, definitely needs to include all of these different systems in order to maintain that metal in circulation. And if the US doesn't have infrastructure for this type of processing, there's just going to be materials that are lost.
This is a question from earlier from Prem. Prem, are you on the call right now? Prem, because I'd rather you speak than just chat.
I am.
Wonderful.
I am. Nice to meet you.
Hi, Prem. Nice to meet you. Yeah.
So my question is, when you went back to the overall process chart and you showed the recovery streams, it was a great chart, and you sort of showed that I think it was about 20% has formal recovery, and there's 86% not going through formal processes and recovery. Yeah, that one, 82%. So what's your take on of that undocumented e-waste? How much of that is actually being recovered?
Yeah, that's a really good question. And there is certainly some that is still going back into the system and being processed by end processors and smelters. But the difficulty there is that, and maybe my colleague can answer this as well, if you're not processing through sort of, if you're only focusing on recovering sort of one or two elements, there's sort of a lot of other elements that are lost in that recovery process. So more informal recycling processes might focus on really valuable materials from an economic perspective, but maybe not recovering materials that are more difficult to consolidate and put into a form for recovery. So I don't know the actual percentage of material weight-wise that would be recovered, but it's much less from a critical metals recovery standpoint if it's not entering the formal recovery system. But there is potential. Yeah, I think there is potential to sort of merge the strength of both the informal and formal recycling system, though. There's sort of thought processes of things that are actually done quite well in the informal waste management system that can be learned in the formal system. But that's, I think, a whole different discussion that we might not have time for at the moment.
So, thank you.
Mm-hmm.
So, sorry, need more coffee. Carrie Mae George, you there?
Yeah, I am. I
Wonderful.
just had a question, and I think this relates to multiple conversations that we've had today, but where do you see and how can we move forward interoperability? The technology systems are there, but until we start scaling, and scaling will mean that it's not one ring to rule them all, but one protocol or one operating style that will help us all interact. What are your thoughts? How are you looking at this? Where's your stage of development to get towards an interoperable kind of engagement?
Yeah, that's a really important question. And I think it goes a bit to the platforms discussion that we had previously. And I think platforms that are able to pull together stakeholders across these different value chains are really what's going to be driving this innovation and conversation. Pulling in the emerging technologies as well, as my colleague will be talking about, to be able to provide a platform and communication channels to identify these solutions that are required for increased recovery. I think there's that conversation's happening on the manufacturing and producing side, but the missing piece of the recyclers need to be brought into that conversation for systemic change to happen.